We have in this unit taken a look at limits to see what a function will be doing at a particular x value. When that x value is a known value like 1, 2, minus 4, it's very easy for us to see what the function is doing. Was it continuous? Did it have a discontinuity? Was that discontinuity a removable discontinuity? Or was it a jump discontinuity? In this video, we're going to take a look and see what our function is going to do as our x value gets bigger and bigger. In other words, what is our function going to do when our x value is tending to infinity? You can see in the diagram that I've got here, as my x value tends towards infinity, my line is going to continue as a horizontal line. That horizontal line went through a y value of c. In other words, as x tends to infinity here, the y value is going to remain along that horizontal line of c. In this picture, you can recognize that you've got a hyperbola. Now, you already know that a hyperbola has a horizontal asymptote that the graph tends towards. But at the moment, I'm just going to take a look and see what is that line, that horizontal line, that y is going to be, in other words, the function is going to be, as x tends to infinity. Now remember, if I say that x tends to infinity, it can tend to infinity in a positive direction or in a negative direction. And as my graph carries on curving, you will see it will continue curving towards the line that I have drawn over there where y is 0. It's going to get closer and closer and closer to the line when y is 0, never actually reaching the value of 0. In other words, in this graph, my graph is going to tend towards 0 as x goes towards infinity. This happens whether I'm going in a positive direction or if I'm going in a negative direction. You can see even though I have the negative x values that are tending towards negative infinity, my graph is still tending towards that line of 0, y equals 0, but never actually reaching it. Now, a horizontal asymptote is a very good way for us to know what our graph is going to do, because you can see that as x tends towards infinity or negative infinity, I'm going to tend towards the y value of that horizontal asymptote. Once again, over here, I've given you a hyperbola. Now, because I gave you the sketch, you can see that it's a hyperbola. But if I had written this slightly differently, you would have recognized it from the expression as well. So this f of x function is actually 1 all over x plus x all over x, which is 1. Now, you know by doing this in your core mathematics that if I say plus 1, I've shifted my hyperbola 1 unit up. But let's take a look and analyze it according to my x values as I did in the previous slide. If I take a look at my x values and I see what's happening as my x values get bigger and bigger and bigger, in other words, as they tend towards infinity, what is my graph doing? Well, my graph in this case is coming closer and closer and closer towards the line when y is 1. So the limit at infinity is going to be 1. At negative infinity, I have the same result. In this case, my graph is also going to tend towards the limit of 1. How would I have known, though, that there was a limit? Because there isn't always a limit, because there isn't always a horizontal asymptote. Well, I'm going to give you a method that can work it out without you being able to see it pictorially. If I take this function and I say to myself, but what would the limit be? In other words, what would the y value be that I'm tending towards as the x value tended towards infinity? In order to do this, what I'm going to do is I'm going to divide the numerator and the denominator by the highest degree of x in my denominator. Now you can see that in my denominator I have x to the 1, so that is the highest degree of x. By dividing both the numerator's terms and the denominator by x to the 1, I get the following. If I simplify this, then I'm going to find that this limit, as x is tending towards infinity, is going to be 1 all over x plus 1, and that is still all over 1. Take a look at that value of 1 over x. Did you remember that I said to you that the x values that we're looking at are the huge x values as they get towards infinity? Now, if I have 1 over x and I take a look at that little fraction, if I have, say, 1 over 2, that's quite small. But if I increase that x value and I now have 1 over 4, that's a lot smaller. Well, 1 over 99 is still an enormously amount smaller than that. And 1 over a million is quite small. In fact, you probably wouldn't be able to see it too easily with your eye. But 1/1,000,000th is still not at infinity. In other words, as these fractions get smaller and smaller and smaller, the value that I have for this little fraction here with a denominator which is tending to infinity is actually so small that I can discount it, because it's eventually going to be 0,00000 before I even get to a value. So the limit in this case, as x is tending to infinity, is actually going to be 1 over 1, which is 1. This graph, we noticed from the previous slide, does tend towards 1, because when we looked at it pictorially, we could see that we were tending towards that horizontal asymptote of 1. So working it out algebraically, we have just been able to prove the same fact without having to resort to looking at the graph.